Ignition sequence start.
Good morning. You've got a view into the International Space Station Flight Control Room at NASA's Johnson Space Center, where the Orbit 2 team of flight controllers is monitoring the performance of station systems and helping the Expedition 66 crew members as they move through the last few hours of their work week on orbit. Commander Anton Shkaplerov and his crewmates have 2 spacewalks on the schedule for later this month and have begun making preparations for them, while doing work on a whole variety of science research that includes some of the pictures they take of the planet below them.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Nilofer Ramji. Recent results from a study on astronauts' Earth photography and a very busy March is ahead of us. Activity continues aboard the space station. A picture is worth 1,000 words, but images from the Crew Earth observation experiment have value that is beyond words. Crew members aboard the space station use a wealth of digital cameras to record how the planet is changing over time. One study used satellite imagery and data pulled from crew photographs to computationally model nighttime light. It provides a unique perspective of light spectrum signatures and the difference between outdoor lamp types, resulting in statistical maps of the relative contribution of different lamp types. You can access more than 3 million astronaut-taken Earth images online, thanks in large part to the Crew Earth Observations experiment. There is an old proverb that the month of March comes in like a lion and goes out like a lamb. Well, the opposite can be said for this March, at least in human spaceflight. Activities on orbit start to rev up on March 15th when Kayla Barron and Raja Shari step out of the airlock to prepare the station for the next installment of the IROSA power channels. As always, you can see the spacewalk on NASA TV, nasa.gov, or the NASA app. We will have a preview of all spacewalk activities for the month when we host a briefing from Houston. March 15th will also mark a milestone as NASA astronaut Mark Vande Hei will surpass Scott Kelly as the U.S. record holder for the longest single spaceflight. A few days later, on March 18th, the Soyuz MS-21 crew launches from the Baikonur Cosmodrome and arrives to the space station just 2 orbits later. Then, the crew is outside the space station again on March 23rd for another U.S. spacewalk, where they will replace the radiator beam valve module hoses. On March 30th, the undocking and landing of Soyuz MS-19 will return NASA astronaut Mark Vande Hei and Russian cosmonaut Fyodor Dubrov to Earth following the American record of 355 days in space. And finally, at the end of the month, the launch from Florida of the Axiom Space AX-1 mission, the first all-private crew to visit the space station. You can stay updated on everything on station by following us on Twitter at @space_station. That's Space to Ground for this week. Thanks so much for watching. We'll see you next week.
Astronauts Raja Chari and Kayla Barron have started the early preparations for the spacewalk targeted on March 15th. But the truth is that preparations for a spacewalk actually begin long before the crew members even launch. In this demonstration video, astronaut Ricky Arnold shares some of the training astronauts get on the ground to be ready to walk in space.
Welcome to the Quest airlock on the International Space Station. I'm Ricky Arnold, Expedition 56 flight engineer from NASA. Today we're going to talk about one of my favorite topics, extravehicular activity, or EVA. Going out on an EVA or a spacewalk has been one of the most amazing experiences of my life. But it's also one of the most complicated and dangerous things we do during human spaceflight. There's a lot of equipment to prepare and maintain, and we do months of training to make each EVA a success. If you think it sounds complicated, you should see all of it in action. Let's start with training and how we get ready for a spacewalk.
Space is an extreme environment that presents many hazards. If we're going to go outside the safety of the ISS, we have to be prepared. That's why EVAs are designed with safety as the utmost priority. We astronauts spend a lot of time in the classroom, just like you are now, learning about the hardware we'll be using and the specific parts of the space station we'll be working on. Then we get to go spend a lot of time training in NASA's giant pool called the Neutral Buoyancy Lab, or NBL. Since it's impossible to simulate microgravity on Earth, the next best option is water. 6.2 million gallons of it. The NBL is 40 feet deep, 202 feet in length, and 102 feet in width. A lot of room to have a full-scale working model of the ISS, which we need for practicing our EVA maneuvers and assigned tasks. We get suited up and weighted so that we're neutrally buoyant in the water, so we don't sink to the bottom and we don't float to the surface. It's a great way to simulate the microgravity we'll be experiencing. We do several dress rehearsals of the EVA before we launch. This gives us the opportunity to prepare for any anomalies that may occur. We spend at least 5 hours practicing in the NBL for every 1 hour planned for the spacewalk, so we are very well prepared to execute the EVAs once we are in orbit. Once we are up in orbit, the EVA preparation continues. First, we must perform a pre-breathe protocol to displace the nitrogen in our tissues and help prevent a condition called decompression sickness. During pre-breathe, we breathe 100% pure oxygen and do some light exercise to help purge the nitrogen from our bodies. During pre-breathe, we will also don our extravehicular mobility unit, or EMU. This is a fancy name for a spacesuit. The spacesuit is basically its own spacecraft, shaped like a human. There is usually a red stripe on the leg of one astronaut, but not the other, so the ground can tell who is who. To ensure our safety at all times, we are always aware of our safety tethers and where we are in relation to our spacewalking buddy.
Hey, buddy.
There's a fellow crew member called the IV, the intervehicular crew, on the inside of the airlock, watching and communicating with us as the EVA progresses. We are also prepared for several contingencies should they occur. First, we are trained on the use of a jetpack that can be used to maneuver in the event of an emergency rescue. It's called a SAFER, or Simplified Aid for EVA Rescue.
The view during an EVA is magnificent. It's beautiful out there. It's also extremely dangerous, but our months of preparation and all of those dedicated people working on the ground, working around the clock, ensure we are safe as possible when we work outside the ISS. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view, unbelievable. See you next time.
International Space Station science research is being used to teach humans more of what we need to know to explore out beyond Earth. For example, biomining could offer a way for crews to obtain needed materials on other planetary bodies. But microbes and rocks interact differently outside of Earth's gravity than they do here, and that might affect the output from extraterrestrial biomining. So, there's an investigation on the station studying how microbes grow on and how they alter planetary rock.
The International Space Station will soon host some of the smallest miners in the universe, microbes. Microbes growing on the surface of rocks can gradually break them down and extract useful minerals and metals. This is a process called biomining. As we explore space, we are seeking to use biomining to turn rock and regolith into soil for growing plants and food. But before we can use this technique in planetary settlements, we first need to test it in space. On the space station, bioreactors will be placed inside a centrifuge where microbes will grow on rocks in microgravity and simulated Martian gravity. Investigators will examine how 3 types of microbes behave within pieces of basalt and evaluate how well the different microbes extract elements from the rocks. Findings will be compared to ground-based results. We We hope to gain insights into how microbes interact with rocks in microgravity and how we might use them in our exploration of deep space.
The International Space Station is a laboratory in space where scientists can remove the constant of gravity from an equation in ways they just can't do on Earth. It's a trick that can be especially useful in the natural sciences. For example, researchers are working to learn how surface tension and capillary flow can be harnessed to improve systems for moving fluids in microgravity, like moving propellants in fuel tanks during space travel. The exterior of the International Space Station is a great place for science. Over on the Kibo Laboratory's exposed facility, there's a package pointing a laser light down to tree canopies on the planet to study Earth's ecosystem for scientists who want to learn more about how it's changing.
Shining laser light on Earth's forests. Presented by Science at NASA. The International Space Station, or ISS, is sporting a new light fixture. The Global Ecosystem Dynamics Investigation, or GEDI, will beam down laser light on Earth from the orbiting laboratory to reveal more about our environment and how it is changing. NASA's GEDI sends laser pulses into tree canopies and precisely measures the light reflected back. The timing and intensity of light that bounces back to GEDI's telescope will reveal the height and density of trees and vegetation, and the vertical arrangement of the leaves and branches within the overall canopy. Dr. Ralph Dabaya, GEDI principal investigator at the University of Maryland, says, "This instrument will map forests in high resolution and 3 dimensions, revolutionizing the way researchers monitor them." Forested areas are an important part of our planet. Not only do forests provide a habitat for many species and a source of raw materials for human use, such as paper and lumber, they also play a key role in the Earth's carbon cycle. Deforestation and forest degradation, in addition to other types of forest disturbances, such as fires and insect outbreaks, lead to increases in atmospheric carbon dioxide. Forest regrowth sucks that carbon back down into trees and soils. Knowing how forests grow and change over time can allow us to better understand the contribution that forests make to Earth's carbon cycle and help people better manage this important resource. GEDI is the first spaceborne instrument designed specifically to perform sustained mapping of the spatial distribution of the carbon content of forests. Dabaya notes, one of the most poorly quantified components of the carbon cycle is the net balance between forest disturbance and regrowth. GEDI will help scientists fill in this missing piece by revealing the vertical structure of the forest, information we really can't get with sufficient accuracy any other way. JEDI will provide scientists with insights into the amount of carbon stored in forests. When combined with current and historical records of changes captured by Earth-orbiting satellites, such as Landsat, this information will enhance the ability of researchers to identify changes happening across our planet. Researchers also will incorporate JEDI's observations, along with those of the ecostress instrument on the station, with data from other current and future Earth-observing sensors. These data will address important questions about relationships between forest structure, function, composition, and changes in carbon content. Combining all of these data will allow researchers to gain an unprecedented understanding of ecosystem dynamics and the role plants and trees play in Earth's global carbon cycle. These new insights could be used in turn to improve models for forecasting future ecosystem changes, atmospheric carbon dioxide concentrations, and climate. JEDI was launched to the station aboard SpaceX CRS-16 on December 5, 2018. For more about how NASA uses the power of light to understand our world and beyond, visit science.nasa.gov.
The astronauts who flew to the International Space Station on NASA's SpaceX Crew 3 mission had been working together for more than a year before their launch last year. Yet you might be surprised to learn that they did not know everything that there was to know about one another. Well, watch as Rajachari, Tom Marshburn, Caleb Barron, and Matthias Maurer politely disagree about who on the crew is the funniest and who has an annoying habit. Find out which of them is the most perspicacious and who said smorgasbord and why.
Raja is super fast at analysis.
Funny, caring, and competent.
And he's super talented, super skilled, a lot of fun to work with.
Tom Marshburn, I would say creative and a teacher.
The silent, quiet part, but with a lot of experience.
Wise.
Kayla is a great communicator.
Perspicacious.
So much experience being in confined environment, keeping calm.
Matthias is a constant innovator.
Inventive.
Innovative.
The funniest must be Grinder. That's Raja.
Grinder.
Raja.
Tom's he doesn't talk about it a lot, but he's done a lot of crazy mountain climbing.
Tom Marshburn is the most adventurous.
Good question, Matthias.
I think that would be me.
Primarily looking out the window with each of them individually and just doing stupid human tricks together.
Enjoying the time off work, watching down towards our beautiful planet and just sharing our dream.
Probably hanging out in the cupola and just looking down on the Earth.
I think coming up with some crazy concoctions made up of expired food that we turn into a smorgasbord. I think Kayla might win if we span it out over time because she has the ability to sustain snacks for a very long period of time.
It's like Kayla loves a big breakfast.
Probably me or Grinder, unfortunately.
Probably Kayla.
Kayla.
Probably Tom. I don't know. We should have one. Find out.
Probably talking to myself when I'm thinking.
I think I've started having more inner monologues or things I'm saying under my breath that I got from Tom Marshburn.
I should ask them that, though. Let me know what they say.
Probably me.
Probably me.
That'd be me.
That's me.
The effort to design and produce the hardware we'll need to explore the moon on Artemis missions isn't restricted just to NASA engineers and scientists. We have a program that reaches out for the particular expertise of today's college students for their help in developing the software and technology to create those needed new tools. Take a look at what the SUITS program is doing for exploration and for student education.
NASA is building exciting new technologies to help astronauts explore the moon, and it is tapping into the unique perspective of today's college students to contribute research to those new tools. Today is test day. NASA engineers are helping evaluate software designed by students. The task is to see how this technology can help during a space mission. It's the culmination of the students' hard work on the program known as SUITS.
So SUITS is Spacesuit User Interface Technologies for Students. What that means is we're having students design a graphic user interface for the suit helmet bubble. You know, a heads-up display would be something that's fairly far out from your face, so maybe a couple of feet or further. What the students are using is a head-mounted display, and we really kind of refer to that as a heads-on, like it's on the head, and so it's only maybe a half inch or so away from the eyes, and they wear it like goggles. It allows them to not only see the real environment in front of them or around them, but also it overlays text or imagery in front of their eye so that they see that on top of the real environment.
Seeing both the graphic overlays and the real environment is called augmented reality. The challenge for the students is to use this technology to be of help during one of the most difficult tasks encountered by humans in space.
So an EVA, or an extravehicular activity, a fancy word for a spacewalk at NASA, is typically a crew member leaving their vehicle, their spacecraft, in a pressurized suit. EVAs are oftentimes, if you ask an astronaut, they'll say that they're much like doing brain surgery and running a marathon at the same time. What we do with suits is simulate this intense EVA environment, but we then introduce an augmented reality display in harmony with the audio feed that comes over the loop from mission control.
Astronauts today don't have augmented reality visible inside the space helmet during an EVA. They rely on their training, mission control, and in some cases a small booklet known as a cuff checklist should they need more information. The SUITS project challenges the students to look forward and wonder, what if astronauts could access data using this technology? What would it look like?
Yeah, I think SUITS is an awesome program and asks teams to create some kind of user interface. It can be virtual reality or it can be augmented reality, but the goal is to basically build a tool that astronauts can use when they're doing space operations.
Students come up with ideas that run the gamut of EVA activity, such as operating complex equipment, cataloging a lunar sample, or navigating to a remote location.
Our main goal was to build a minimalistic and unobtrusive interface that's easy to use, so we made sure to develop exclusively natural inputs like hand gestures and voice command to control the EVA system.
NASA mentors and academia sponsors help the students achieve their goals.
It was extremely constructive altogether. I would like to say that we riled each other up positively, in the sense that we were able to achieve greater things, because at every meeting we would say, hey, what if we do this? Hey, what if we do that? Hey, wouldn't it be awesome if? So overall, we were positively reinforcing each other's interests.
NASA engineers evaluate the students' work by trying out their ideas in a simulated spacewalk, so that they and the students see what works and what needs tweaking. It's a unique educational experience.
Even though we had some technical issues while testing, it was very surreal to see our tool being tested at Johnson Space Center. My favorite part about working with the team is that everyone was very excited to learn and also share what they know. We all come from different majors and different backgrounds, so by the end of the cycle, everyone knew a little bit about rocks or about programming, or got out of their comfort zone by presenting our project.
It also helped with interpersonal skills, learning how to work within a team, improving my technical communication. I can talk about systems and software, helping me be more confident in my abilities.
It's great to see them grow. It's great to see them collaborating with each other, collaborating with subject matter experts to make their designs more effective or more efficient.
The research gathered in Suits benefits NASA too, as it develops its own designs for possible graphic displays. It's future-forward work that is needed now.
When I entered the field of augmented reality for EVA displays, there was about one paper that I could reference. What Suits provides to the engineers at NASA is really the ability to explore many different designs, to explore many different concepts, and really have a think tank, if you will, for what the future of these displays really look like.
All the hard work, testing, and learning points to a brighter future using this technology.
It's an amalgamation of doing something that I love and also seeing the value that would come off of it in the long run. And I think that's the same for most of my peers as well who worked in this project. You could see some real, genuine passion in working on this, and everything shows that we really want this to work. We really want tech and space exploration to be the next big thing. And that was super satisfying and fulfilling to me and to the team as well.
Building this software for these displays is like giving the crew members superpowers, and that's something that I love about it, but also getting to engage with academia and the talent that we have in academia and in universities. That's what we need to see, and the creativity that comes from it to make these tools the best that they can be. With NASA Suits, we want to see your vision. Your vision.
With NASA Suits, we want to see your vision.
Your vision.
This is NASA Suits, and we want to see your vision.
Visit stem.nasa.gov/Artemis and see how you can join one of NASA's mission-related student challenges.
If you want another look at any of the stories we showed you today, head over to YouTube and Facebook. You'll find them all there, along with lots of other great features on a whole variety of NASA topics. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. It's our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan talks to the chief engineer of NASA's new mega rocket, the Space Launch System. Gets an education about the machine and its components and how it's going to carry Artemis astronauts to the moon. Go to nasa.gov/podcasts for this week's episode. All the previous episodes are there too. So are all the other NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud. You can get the latest from all over NASA delivered to you every week if you go to nasa.gov/subscribe and sign up for the NASA newsletter.